Okay, let's see if I can get this sharing and then we'll get going. Okay, perfect. Nice. Okay, perfect. So we left off class by talking about long division. Now we're at synthetic division. So we have the start to the setup. We are dividing by to zero. Remember, if the factor is the -4, x minus 4, then the zero is the 4. So that's how we got this number. Then we only use the coefficients of the equation. So that's the 2, the -6, the -7, and the +6. So what we do there is, I'm noticing I'm missing my negatives for the 6. So only coefficients. So above in that like olivey green, I have the x cubed, x squared, x, and constant. And below is the x squared, the x, the constant, and uh, the leftovers. Why can't I think of the word? Um, yeah, the leftovers. I cannot think of this word right now. Remainder. There we go. So how we get this ball rolling is we drop the 2, and then it's 4 times 2 up and over, and then we add down, and then you start again. So it's 4 times 2, that goes up and over, so that's 8. So then we add down, so that's 15. Then again, it's 4 times 15 to give what? 60. And then, sorry, my computer's asking me questions. And then we add down, so 66. Okay, so we now have that 2x cubed minus 6x squared minus 7x plus 6 divided by x minus 4. Let me choose C. The full quotient is 2x squared plus 2x plus 15 plus 66 over the original divisor, which is x minus 4. Okay. So let's practice another one. The setup, right? We have this upside down situation. Then we have the coefficients of all of the terms, making sure that if there are any zeros, if there are any missing terms, if any missing terms, 0 placeholder. And I mean, literally, you put a 0 in, not like there's no placeholder. I mean, like you have a 0 for that placeholder because we need every slot filled. We need the fourth, the cubed, the squared, the x, and the constant. Then below, because we're just dividing by x, we are just basically subtracting an x from every term. So that's why we go from a fourth to a cubic cube, and then you just go down by 1. Okay, that's the R for remainder. Usually we do put this little, like, I don't know, block to separate, like, oh, this is the remainder. That's not necessary. It's not like a technicality. It's just like something we do. All right, so here, if the factor, right, is x plus 5, then you take it, you set it equal to 0, and solve. So this -5 is what we divide by. So that goes out there, and on the inside are all the coefficients. So 1, 5, -3, -13, and 10. To get the ball rolling, you drop the first term. So that's 1. And then you multiply, I think of it as a check mark. So multiply -5 times 1 is -5. Then you add down. Then again, up and over, multiply, add down, -3, up and over, multiply. Let's see. So -5 times -3 is 15. Then add down. So that's a 2. And then -5. So times 2. I think of it as, like a check mark. That is -10. So that is a 0 remainder when we add down. So you multiply and add, multiply, add, multiply, add. Perfect. So here, I like that this is a zero remainder. It tells me that the -5 goes in evenly. But we ultimately know that the quotient is x cubed minus 3x minus 2. I know that there's not an x squared term because we have a 0. You can write 0x squared, but we know that that'll just zero out. So this also tells me that this, let me change that, let's see. This polynomial factors, so that actually equals x plus 5 times x cubed minus 3x minus 2. And then from here, we could just keep factoring down to get zeros. So one thing about this being a zero remainder, it tells me that this is a factor. Okay, so it goes in evenly is what we mean by that. So if I'm dividing here, -9x to the fourth plus 10x cubed plus 7x squared minus 6 by x minus 1, use synthetic division. I want you to pause the video and try it yourself and then play when you are ready. Okay, so if this is the factor, we're going to set that equal to 0 and solve, or set the factor equal to 0 and solve. So this is the 0. That's the number we divide by. So it's 1 going into -9, 10, 7, 0, -6. Because recall, we have an x to the fourth, then the third, second, 1 constant. Below, remember we represent 1 down, so the x cubed, cubed, squared, first the constant, and then the remainder. So let's see. Do y'all remember how we get the ball rolling? Drop the first number. So -9 times 1 is -9, add down, that's 1. Check mark, multiply, so 1 times 1 is 1, add down is 8. Check mark, right, up and over, multiply, so that's 8, add down, that is 8. 1 times 8 is still 8. Add down, that is what, 14? Okay, so the full quotient is -9x cubed plus 1x squared, you can put the 1 or not, plus 8x plus 8 plus 14 over x minus 1. That's the full quotient. So here, since we had a remainder other than 0, I know that x minus 1 is not a factor of this polynomial, right? It does not go evenly. It does not go evenly. So then the remainder theorem, like I said, the remainder theorem, in my opinion, is like, yeah, cool, okay. But am I really going to use it a ton? No. It's just one of those things where it's like, okay, great. Good to know. But again, it's just like extra bonus material. Okay, so if a polynomial f of x is divided by x minus k or x plus k, then the remainder is the value of f of k. Remember that I called this is called the function value. It was on test 2, right? Like if this is your graph, like f of 0, well, that's 0. Or if I had, so this, where it's filled in, that's the function value. Okay. Function value, the value of the function, right? They called it like they saw it. So given f of x equals 2x to the fifth minus 3x to the fourth minus 9x cubed plus 8x squared plus 2, use the remainder theorem to find the remainder when f is divided by x plus 3. Okay, so here's the proposed factor. We are going to set that sucker to 0 and solve. So x minus 3 is the number that we are going to divide by, because we were doing this with synthetic division. So I want you to pause and try synthetic on your own. Play when you're ready. So -3, and then we have a 2, a -3, -9, 8, a 0, and a 2. Because notice I go 5, 4, 3, 2. I'm missing the 1 and then the constant. Remember, to get the ball rolling, the 2 drops. Then it's -3 times 2 to get -6. Then we add down. So that is -9. Then -3 times -9 to get what? Positive 27. Positive 27 minus 9 is what? 18. -3 times 18. My brain's not that fast. Let me slap it into my calculator. -3 times 18, 54. -54. Adding down. So take away 8, that's -46. Now times the 3, that is 138. Add down. So 138. Okay. Let's see. -46, add down 138. There we go. Then 138 times 3, -3, is -414. Let's see, that was kind of squished. -414. And then we add down -412. There we go. That's the remainder. So the quotient or the remainder or the value, so f of -3 is -412 using the remainder theorem. Yes, could I also just do, oops, hang on, sorry. Could I just do f of -3 is 2 to the -3rd to the 5th minus 3 times -3 to the 4th minus 9 times -3 cubed plus 8 times -3 squared plus 2? Totally. And if this was real life, would I? Totally. Again, like I said, the remainder theorem is just like bonus, like, oh, that's really cool and interesting. Like we can use it in other places. But as far as like this class, remainder theorem, in my opinion, is just like bonus fancy information. So now the factor theorem. The factor theorem, this is the one that is really just looping a bunch of information together. I think it's just a fun theorem that says, this is why we learn all of these things. So here we go. The number k is a 0 if a polynomial f of x, the number k is a 0 of a polynomial f of x, if and only if x minus k is a factor of f of x. So if it's a 0, right, that means an x-intercept. We know that from last week or something like that. That means it's an x-intercept. We know that it's an x-intercept if x minus k is a factor. So this is really what we've been saying all along, right? Because if I got like from quadratic equations, say, I don't know, 0 equals x minus 2 times x plus 1. We said, okay, then x equals 2 and -1 because we set each factor, right? These are factors. We set each factor equal to 0 and solved, right? The zero product principle. That's what we did starting day 2 of class, something like that. Day 3, day 1. It's just looping everything together in like a nice little bow. The factor theorem. So we get zeros from factors, we get factors from zeros, all that fun stuff. It's just kind of putting everything in a nice bow, a nice package. That's it. So given f of x equaling 3x to the 4th minus 3x cubed minus 33x squared plus x to the 54x, pardon me. So given this equation, A, determine if x minus 2 is a factor of f of x using the remainder and factor theorems. So what that says The remainder theorem says, well, if it is, then the remainder will equal 0, right? Because factors go in evenly. Go in evenly, if you would, right? From what we saw up, where was it? Right from example 5, okay? That's how we know, like, oh, yay, this is a factor because I have a remainder of 0, blah, 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 blah. Fun stuff, fun times. And then the factor theorem says, okay, if it goes in evenly, then yes, it's a remainder because the remainder says that this is f of 2 is equal to 0, which tells us, yes, this is a 0, right? So this is why it gets so cool. So remainder theorem tells us the remainder is 0, which tells us the function value is 0, which tells us that, yes, it is an x-intercept, which tells us, yes, if it's an x-intercept, it is a factor because a 0 is an x-intercept. Okay, so pause the video, practice synthetic division. So 2 goes into 3, -3, -33, 54. Let's see, and then 0 for the constant, 4, 3, 2, 1, 0. So drop the 3. That's a 3. 2 times 3 is 6. Add together, +3. Check mark, right? Open over or down and over, I guess. 2 times 3 is 6. -33 plus 6 is what? -27? Double check my math here since I don't have y'all. 33 and 6, yeah, -27. Then times 2 is -54. Oh yeah, look. Okay, and then that's 0. 2 times 0 is 0, which is 0. Cool beans, right? So there's the remainder. And then if this starts with a 4, then here, this represents the x cubed term. So determine if it's a factor. Yes, it is a factor because we had a remainder of 0. So B, if it is a factor, yep, it sure is. Finish factoring. So again, let me see, let's get a good color. Red's fine. So I know that this says here, we factor into the x minus 2, because that's from right there. And then we have the quotient, right? The quotient, 3x cubed minus 3x squared. Oh no, plus 3x squared, excuse me, minus 27x. Okay, so then we can keep factoring. So here, those have multiples of 3 and all have an x. So we are going to factor a 3x out. And when we do that, we have x squared plus x minus 9. And then what? -9 plus x. That doesn't factor any further. There's no two numbers that multiply to -9 yet add to 1. Right, because 9 is 1 and 9 and 3 and 3. Right, let's see. Yeah, I'm just making sure. Yes, yes, yes. Checking my math on my calculator off screen. 27 divided by, whoops. Yep. Okay, perfect. Yeah. So then here are factors. So this is unfactorable, doesn't factor any further. I don't think. Let's double check. Let's see. Where is my calculator? Here we go. When in doubt, let's see. Let's go to y equals. I believe it's a quadratic that opens up and is above the x-axis. So thus, it would never cross the x-intercept. Let's just make sure I'm in a zoom 6 standard. Oh no, I lied. Okay, it just has funky. It just has wonky. Because notice right here, whoops, that we are crossing the x-intercept. So we get to do some fun quadratic equation. Well, actually, here, let's just do second calc for 0. So I'm just going to move it left bound. That's good. Yep. And then right bound, that's good. Enter. Okay. So I have a 0 at negative 3.54. Negative 3.54. And then let's find that other one. Come back. Okay, so then second calc, 0. Gonna move this over here. I'm gonna press enter, move it over for the right bound, enter. So this 0 is, let's see, 2.54. Just rounding. 2.54. There we go. So from here, we see that x is equal to positive 2 and 3. Then we get the others. If it says it wants exact solutions, use quadratic equation. Use the quadratic equation. Okay. Oop, let me move that arrow actually. That was a comma. Doo-ba-doo. For exact equations. Use quadratic. All right, so example 9. Use the factor theorem to find all zeros of f of x. Given, you solve the equation given that 2 is a 0. Let's see. Let's just skip 9 for time and we'll just do 10. So again, I'll do synthetic division whenever it's an option because it's just obviously way easier. So pause the video and give it a go. So 2, and then this, again, this represents the cubic, the squared, the first, the x, or excuse me, the x is that, and the constant. So again, that's x cubed, x squared, x to the first, and the constant. So I have a 1, a 0, a negative 7, and a 6. Drop the first number to get the ball rolling. And then remember your like reverse check mark is multiplication. So 2 times 1 is 2, and then we add down. Now 2 times 2 is 4, and we add down. 2 times negative 3 is negative 6, and we add down. So we see that we have a remainder of 0. So this is my x squared, my x, my constant, and the remainder. So it is a 0, so verified. Verify. Not verified. It is a 0. Yay! Yay! Perfect. So this tells me that x cubed minus 7x plus 6 factors into x, remember to be minus 2, because if 2 is the 0, this says that x equals 2, so I just subtract that sucker over to find the factor. Oops, here, let's see. This is the factor. All right, so then the quotient is now what goes here. So that is the x squared plus 2x minus 3, and we factor it. So that's x minus 2, and then 3 is prime, so it's 3 in itself. So it's x minus 1, x plus 3, because I need minus 1 plus 3 to add to positive 2. Oh, hopefully this is sinking in. Okay, up next, rational functions. I'll do it in a different video.